The binomial distribution. Let's start out in the menu again. We're in statistics. Show you the distributions I'm in. I'm currently in distribution. I choose binomial, which is F5. I've got three choices: binomial PDF, binomial CDF, and inverse binomial. The inverse binomial is a very powerful calculation that will find the area between given values. Let's start with the binomial PDF. We're going to go based on the variables. This is the number of successes in a given number of trials. So we're looking for 9 successes out of 10 trials, and the probability of finding success is 0.1. So to give it context, let's say we're looking at testing light switches, and the probability of finding a light switch that is bad, that would be a success, or a failing light switch. That's a success in this case. We are not going to save the results, so those results will not be saved. We'll save those in a minute. We're just going to go ahead and calculate that. So the probability of finding 9 bad switches out of 10 switches chosen at random is that very small number, 0.00080 zeros and then a 9. So 9 times 10 to the negative 9th. All right, let's try a different calculation with the binomial. Let's go based on a list. But before we go into the list, let's take a look at what we have here. This is 0 switches, 1, 2, 3, all the way up to 10 bad switches out of 10 trials. I'm going to delete the information that's in the list 2 because I'm going to use list 2 in a second. And then we'll go into our distributions again. Press F6, distribution, F5 binomial. We'll do binomial PDF for any given value. This is going to look in list number 1, 0 through 10, and find the probability for each one of these. I am going to go ahead and save that result into list number 2, and then go ahead and execute the calculation. I want to exit because I want to take a look at this distribution as a histogram. So I'm going to set up a graph, set it up to make a histogram from list 1 and list 2, and then go ahead and graph it. It's going to ask me what my bin width and my start value are. I want to see some of the x-axis, and every outcome will be its own bin. And here's your information. We can look at the one variable statistics. We can also trace. We can graph that again, look at the one variable stats. Including the mean, maximum, modes, etc. All right, now let's take a look at something different we can do with the binomial distribution. I'll hit exit a few times. Distribution, binomial, cumulative distribution function. Again, I'm going to start with variables. The area between 0 and, let's say, 4 bad switches out of 10 chosen at random. The results will not be saved. Go ahead and execute that. So the probability of finding between 0 and 4 bad switches out of 10, with a bad switch being 0.1 probability, is 0.99. Let's exit and take a look at that. If we add the first 4 values, we do end up seeing that's a majority of the area to the left. So let's take a look now at the inverse binomial and see if we can replicate that solution. So we want to go with 0.99. So we want area to the left, 0.99, and we want to know how many trials is that going to take, or how many switches is that going to be. Again, here's that warning that we get that says the answer is going to be 4. It might give us a 3 because of this area being within 0.01 of the tolerance. We'll say OK. That gives us the 4, which is exactly what we calculated earlier. It's within the tolerance of 0.01, so it may be a little bit off, but that's okay. It let us know ahead of time. Let's pick a different calculation. Let's go half of the area, it being to the left of this value, and then we'll go ahead and execute. And it says it's between 0 and 1, so 0 and 1 will capture about half of your area, which it's over half, but that's okay. That's what we wanted. So that is the binomial distribution calculation.